Morning, everybody. We'll get started in a couple of minutes, so just a few stragglers coming in. Thanks, Linda. Good morning, everybody. Sorry, we're starting a little bit late. Had some issues with the audio, but hopefully it's working now. Before we start, I need to get a couple of people to help me with some note-taking. Can I grab a couple of volunteers? I've got one, two. Anyone else, please? I'm not seeing any hands. Okay, great. Thank you. Okay, well, welcome. Thank you. Again, sorry we're starting a little bit late, but we have plenty of time on the agenda. So let me just run through a couple of things here before we get started with the first presentation. As always, bring up the note well, just making sure that everybody's aware of that. There's a brief summary on this slide that I'd appreciate if you read and look at the necessary documents there on the note well. In terms of agenda, we're going to be talking about the SFC encapsulation today. I think Paul's going to give us an update on where we're at with that. There's been a lot of work gone on between Honolulu and today to consolidate the different encapsulation ideas, and we've been moving forward quite rapidly on that, so we'll get an update there. We'll also look at some architecture stuff, and then look at some interoperability work that's been done, some open source work that's been done, and implementations. So that's kind of the focus of the meeting today. Here's a detailed breakdown of the agenda. As I say, we'll start with the encapsulation. I've left plenty of time for Q&A on each of these sections, so if anyone has questions, please use the mics, and let's utilize the time that we have. In terms of the status of the working group, I'll give you a quick update so far. The problem statement, that completed the IESG review. It's in the RFC queue for publication now. And I, from the chair's perspective, really wanted to thank Joel Halpin for shepherding that document. There was a lot of work went into that. Also the other authors of that document, so thank you very much for that. The architecture, again, we've done a lot of work on that. That's been submitted to IESG for publication. Again, thank you for all of the discussion on the list, and special thank you to Joel and Carlos for really taking those edits and turning the document into a pretty solid document, I think, now. I'll be shepherding that one through the process, so again, thank you. So, Paul, hopefully the mic's working here. I'll get the slides up. Please just, when you want, I'll be driving the slides from here, so just say, you know, next slide, whatever, and we'll be able to do that. Just find the stuff here. That doesn't look pretty, I know. That blinds me.
Testing.
Thanks, Dave. One second now.
Okay. So, good morning, everyone. Thank you for attending. I'll give a relatively brief update on the status of the NSH draft. There's been a lot of discussion on list, and there hasn't been a lot of content changes since the last update, but there's been a major status update change. So if you'll forward through. So I'll give a 2-second review. I know not everyone has read all drafts. NSH is what we've adopted as our SFC encapsulation. It's basically a simple header that we use to construct or realize a service path and a rendered service path in the topology. It provides path identification. It provides an index that tells you where you are in the path, as well as the ability to carry and share metadata. It's divided into 3 big blobs, if you will. There's the base header, which defines the header semantics and some of the bookkeeping information, versioning, OAM, and so on. It provides a path header, which defines, as I said, a path identifier and an index, which gives you your location in the path, and we use for forwarding along a service path. And then it provides either a fixed set of metadata fields, and we went with a fixed set from a ease of implementation, ease of parsing perspective, or a richer set of TLV-based metadata, and they're defined by a type, and implementations can use one, either, or both. Next slide, please. So, I'm going to do this. There we go. So, the big change in this version from the previous is that it's been adopted by the working group. The chairs have appointed 2 editors, Uri Elzer, who's probably in the room, and myself. There he is. All the other co-authors, and there were many other co-authors who contributed quite a bit to the draft, they've been moved to a special contributors section. Obviously, a huge thank you to them, and we obviously expect to all keep working together in conjunction with the working group. One big change through this process that we all agreed made sense was the addition of an open item section. There are several large topics that have been discussed in the working group that need to be resolved. Primarily, the definition of the fixed header. As I mentioned, there's a fixed header portion for metadata. There are 2 companion drafts, if you will, that define the semantics of those fixed headers. There's been some discussion about whether those semantics should be included in the main NSH draft and maybe some rationalization occur. These are still open, by the way. I'm not proposing an answer at this point. There's a discussion of a bypass bit, again, in a companion draft. If we all view as a working group community that bypass is a core function that we want to always support in NSH, then we can discuss adding an explicit bit permanently or codifying it in the NSH. And lastly, and perhaps the most complex topic, and I realize I'm going to get feedback, is this concept of a rendered service path ID, which is used to provide additional data plane information at greater granularity for forwarding along a service path. So the discussion being that a service path is not granular enough and you might need sub-data plane identification within a given service path. And the question is, how do we codify that in NSH? So those are the 3 primary big bucket open items. Of course, there's other things being discussed on lists, and we're happy to continue to work on that, but those are identified in the draft today as items to be worked on. Next slide, please, Jim. Just a quick implementation. I know we have a dedicated session today to discuss it, but for those of you interested in testing, using, starting to deploy, there are open source implementations of NSH available in OVS, and Reynaldo will go into more detail. There's also a control plane implementation in Open Daylight, and I believe this afternoon one of our operators operator from our community will be talking about some initial deployment experience. There's also vendor implementation underway as well. Next slide, please, Jim. So the next steps, the fragmentation section is a bit light in the draft, and by light I mean it has no content or no significant content, so we need to beef that up. We need to review the security considerations for those of you who tracked the problem statement last call. One of the areas of feedback that we got and worked on with our ADs and with sector was to ensure that the security considerations section was adequate and addressed the true security considerations of the protocol, so we need to work on that. If we have security people here, that's wonderful. And lastly, of course, as we discussed, the listed open items need to be finalized before we move to the last call, and of course any other items on list. So that's the status update as of today for NSH. I expect over the next few weeks we will delve into each of these areas in detail, make some decisions on list, and keep moving forward. But it's been The call for adoption was very smooth, very wide acceptance. I think we're in pretty good shape. These should be resolved without too much controversy.
Thanks, Paul. So, any questions, please feel free to come to the mic and it's,
John Messenger, Adver Optical. Just to note on your slides, you still refer to draft Quinn, and when you follow it, it's expired. So that wants updating.
Thank you. Great catch. Yes, the corrected name draft has been submitted and the changes have been made. Absolutely, my apologies. These slides were... my apologies. Yes, I'll update the slides.
There from Telecom. Yeah, just to say that I'm still happy with the current shape of this draft. So as I already mentioned, the mailing list, I will use the issue tracker, the service tracker of the IETF, so that we record the issues and to discuss them, so that it can be easily tracked in the mailing list. So I will issue tickets using the issue tracker of the IETF.
any further questions? That's good. Okay, thank you, Paul.
Thank you.
Okay. Okay, the next few discussions are going to be on architecture type things. I think the header mapping is first, although I'm not seeing this very well on the screen here. Doesn't show the PDFs too well.
What's rendered on?
Hmm.
Was it rendered on?
I don't know. Take a look at it.
On my laptop?
Yeah, let's grab that. The Mac's not liking it. There we go. Perfect.
Okay, sorry about that, folks. Anyway, today I'm presenting draft song SFC Legacy SF mapping. List of authors there. My name is Dave Dolson. Next slide, please. So a bit of history on this draft. This was first presented at IETF 91 in Honolulu. There were some questions raised at the microphone about metadata related to the legacy SF function. I guess since I asked some of those questions, now I'm answering them. So some of the things we've changed. We've added a section to discuss the metadata. But the background for this work is that, it's important, it was mentioned in the architecture that this SF legacy feature exists, and we thought it was important to investigate it and to look at the issues related to it and try to answer some of them. So that's why we've continued to work on this. So some of the updates related to the last version are, we reconciled some of the language with the architecture document, and we added a section on the metadata and tried to clarify the behavior a bit more. Next slide, please. So recall that the point of the SFC proxy is to translate the SFC packets with their, the NSH headers with the path ID and so on, into something that an SFC unaware service function could understand. So this would be a function that doesn't know anything about this NSH header, for example. So the basic idea is that the proxy removes the packet from the NSH header, forwards it to the legacy device, and then when the packet comes back from the legacy device, puts it back in the correct path along with associated metadata and so on. Next slide, please. So there are different kinds of legacy devices, but we are focusing first on what we call the transparent the SFC unaware service function. And the idea here is this is a device that you might think of as you might know it as a bump in the wire. So in other words, it forwards generally all the layer 2, layer 3 information as it received it. So it's not natting it, it's not rewriting the MAC addresses. So there are a few different ways you can interoperate with such a device. Next slide, please. So I won't go into all the details here. The draft discusses all these different methods that you can talk to a legacy SF device with. For example, MAC address approach. This is where you can use a different source and destination MAC address for each different service path that you need to encode. So think of using the MAC address as just a code point for which header needs to be inserted again. In the VLAN one, you can also think of as creating a mapping between the path ID and a VLAN and back again. The 5-tuple approach is the proxy remembers, on the basis of TCP 5-tuple, for example, which path it belongs on. Anyway, the details are in the draft, and I encourage you to read them. Next slide, please. So here's where things get interesting. There are some types of devices that, not only forward packets, but also inject packets of their own. For example, a transparent cache is injecting data from its disk, right? And some of these devices also may need to create an ACK packet or retransmit a packet. You can also see there are some types of devices that need to respond. For example, you can imagine a firewall receiving a packet it doesn't like and wanting to send a reset to it. And this is interesting because the reset packet is not actually on the same path as the packet it received. It's on a reverse path, which it may not know. It may need some tricks to understand what that will be. So we think, there's one type of legacy service function that when it injects a packet, it will add the headers that it saw from other packets of the same flow. So I say, it copies exemplar layer 2, 3 from packet. So for a given TCP flow, just put it on the same VLAN and the same MAC addresses that it saw it on. So that's something you can think about. But then the question of metadata arises. So which metadata should be added to an injected packet? And the answer is it depends. So next slide, please. So we came up with a few different classes of metadata, and where I'm going with this is that not all metadata is the same, and that we shouldn't try to just assume it's all opaque and we can treat them all the same. And by the way, this problem isn't just isolated to the legacy service functions. This problem exists for any service function that wants to inject packets into a chain. There's a question of what metadata should go on. So first class we were thinking of is we call mandatory per packet metadata. So by this I mean per packet. I mean this metadata is just about this packet. One type you can think of forwarding info or perhaps a tenant identifier. I've even heard people talk about, I could put like a checksum or a security token or something on this packet.
Joel Halpern, if I can ask a question.
Sure.
You've put 3 different things together in that line, one of which you've sort of differentiated on the second line, mandatory versus optional. I don't think from the point of view of a proxy it can tell whether things are mandatory or optional because it's much too hard to tell. There's certainly per packet metadata. The reason I came to the mic is forwarding info is not metadata. The way we've structured this, the path ID is separate from the metadata, and we've said the path ID is one thing, the metadata is separate, the SFF works on the path ID and index. Classifiers can work on anything, but not everybody will be using classifiers. So I just get really nervous when I see, for example, forwarding info there.
Okay, so forwarding info may have been a poor choice of term, but there was in one of the companion drafts to I can't remember, was it the data center one or the mobile one, there was some information in there about which destination it should go to or something. So maybe forwarding info is a bad example, but I think tenant ID was definitely mentioned as an example of metadata. So I wasn't talking specifically about the path identifier here and the path index. And another class is optional per packet metadata. So this is metadata which is talking about this specific packet, but if we didn't add it, that would be okay. So maybe earlier we've offloaded some checksum and we've put a tag on here to say, the checksum's okay, you don't have to check it. Or you can imagine a few different ways in which metadata can talk about just the packet. The third class is per transport flow metadata. So by this I mean it's a piece of metadata that's talking about this TCP flow. So it's really legitimate to use the same one for every packet of the flow. And the fourth case is your per host metadata. And the case here that was discussed was some kind of subscriber identifier. And in that case, it's okay to use the same metadata for all flows for that customer. So I'm sure you can come up with some other cases as well. My point here is that there are different classes of metadata, and you can't assume it's legitimate to just add these by copying values from another packet you saw. In some cases you need to compute it, and in some cases you can just copy it from other packets. So what I'm trying to think about here is when we define metadata in configuration layer, when we configure service functions, do we need to provide some kind of a schema in the configuration layer to tell the devices which type of metadata is? So even if we wish it to be opaque to a particular device, can we at least tell it it's okay to clone this from one packet of a flow to another? Or another way of thinking about this is we could essentially forbid certain types of metadata from being used. Next slide, please. Yeah, so we're looking for some feedback from the group. On one hand, we'd like to continue work with this draft. We'd like the working group to adopt this, to continue to get a lot of focus on it, to understand how the SF proxy should work. And on the other hand, we'd like to know what to do with this metadata problem. Should this be explicitly mentioned in architecture or in configuration layer? How do we help have successful deployments, without breaking the network by having poorly defined cloning of metadata, for example? So any questions?
Eric Nordmark. So I think it's important to write down how these things work, right? Because I think we will see these proxies to deal with legacy, whatever service functions. I had two questions. One is about, so you seem to be making some unstated assumptions when you assume you can use the MAC address as a key. At least in my model, I'm thinking this is some random Linux VM, right? And you're sending it a packet, and it's going to do something with it. And it may or may not go through the IP stack, and you might actually end up saying, well, IP is going to ARP as part of doing that. So you don't actually have, the MAC address is not something that is passed through that system.
Right. So
you're assuming that this is basically operating as a transparent device at layer 2.
Right, so you're right, there's some unstated assumptions here. One of the things about these legacy devices is that we're going to need to build, probably a different type of proxy for different type of legacy devices. So for sure there are devices that will just forward as a bump in the wire, but there are also devices that don't. I think a lot of the issues pertain to all of them, but we'd love to add that class of devices to our draft.
Yeah, it would be good to at least state the assumption, and then maybe also if there's people that are looking into, can you make it work with things that sort of run an IP stack and might ARP or whatever, right? And see if there's some other key in the packet you can use to sort of for those purposes. My other question, and this might just be for my education, is for the case of returning the TCP reset type case, how does that work for a non-legacy service function? Is there a notion that I can reverse the path, even if I'm service SFC aware, right? How do I reverse the path to send it back in the reverse direction? Do we already have that in the architecture, or is this a piece missing?
I've asked that question myself. As far as I know, it's not been included. My belief is that in the control plane, when a path is configured, that they need to be paired. In other words, if you need a bidirectional path, I believe there needs to be, this path has this next hop, and oh, by the way, here's a pointer to the other direction so that they can cross-reference each other. But I think that's a control plane thing.
Sumandra, so I see the VLAN or MAC can be used as a key, but I think you also have to use some other fields, because if I'm looking at a cache, it has one MAC and multiple clients are connecting to it. And one classifier might be putting different metadata. So when you are actually copying it, you might have to use key informations that not just takes the MAC, but the flow information or something else. So the couple of questions: do we have enough entropy bits? And how are we going to extract the entropy bits out of NSH header or something else? And the other thing that's a little bit scared me is that when you mentioned that we might need to have a schema for different metadata, that really might not fly in a proxy architecture. I mean, we already have proxies. We are a sort of a proxy company. We see our complexity in the configuration. Adding one more, it's not a pleasant thought. So to your first part, Jim, if you can back up to the slide with the table on it.
Yeah.
So the last one there is the 5-tuple approach, in which the proxy keeps state about which chain each 5-tuple flow was found on.
Now, you may include a 6 tuple there related to a tenant identifier or something, but if you do that, then you still need to know which item of the metadata is the tenant. Okay.
What I'm saying is that you'd be probably forced to always have 6 tuple or more, because a cache or something typically servicing lots of flows or lots of tenants or lots of subscribers. So having VXLAN or VLAN as a key, I think that's most likely will not work in real implementation.
You may be right. I think we should include that in the draft. And sorry, there was a part 2 to your question.
Part two was the question about where you said that we have typically metadata which are optional, which are part flow, which I agree with.
Oh yeah, you were concerned about the
Yes,
configuring
and how do you
metadata.
instruct? So the reason I bring up the 6 tuple is, let's say a classifier puts certain informations for a given tenant or given flow, and now how do I go and represent that on a particular schema? It's going to be very difficult if I have to actually classify a schema based on 6 tuple.
Yeah, so one approach here is to look at the, for example, the fixed metadata for data center. We can look at that and in that draft, explain where each of those 4 metadatas, ensure that these are all of a class that will work here. And just in that document, that could be the schema, could be just by standardization. But if we're talking about type length value type of metadata, then allowing people to just add opaque data there, I think is problematic, and I think there needs to be a configuration or a dictionary or restrictions on what type of metadata you can use.
And lastly, I would really thank you for taking on this difficult subject. So that's good. So we probably have other discussions to do.
Yeah, it's good to hear. Thanks.
Hi, John Messenger from ADVA. Just wondering whether, please tell me if I'm asking a question that's not polite to ask in IETF or not allowed or something. This is a hard problem. Is it actually feasible to solve it at all? It seems to me that the idea of a proxy for SF unaware devices is a very complicated thing to achieve. And it's going to have a lot of state and it's going to be complicated. And it seems like to a naive bystander that it would be an awful lot simpler to simply re-implement all the service functions, all of them in the entire universe, than try to make some general purpose proxy that's actually going to achieve anything. Do you have a process where you go through some existence proof or feasibility proof process before you progress drafts beyond a certain stage?
Well, I don't think that's an in-play question. I think it's really good to question whether something's possible. So I think in the limit, you can have a legacy device by having one device per service chain, or limit it so that this device can only handle one path. And
yeah, but it's got to be one path. Well, maybe like one function of one path, right? Because, like you say, with a device that's got lots of clients, you've got to start subverting the identifier fields in ways that we yet need to understand.
Right. So if you can have one function, if you can have one device only handle one path, I think we can kind of see how that works. So now could I have 2 paths through one device, by using a couple different VLANs? So I believe that it can be made to work. If you can prove it can't work, I guess we need those arguments. And maybe it cannot work with some types of metadata. So I think this is why we need...
follow up. I don't think I'm saying I don't think it can work. I think what I'm asking is it worth it? And I guess at a certain point one has to be able to show that it can work.
That seems like a commercial question to me.
Yeah, that it is.
Mm-hmm. Surendra.
Hey, Surendra from Cisco. I have comments on the same lines as the other speaker. It is challenging to implement the proxy. There have to be considerations, for instance, for the the amount of metadata that is that needs to be preserved, because like you said, you are mapping this entire NSH metadata onto VLANs or whatever is on the other side, right? And there was a case made on the mailing list about large metadata, and then we now have MD type 2, which allows for carrying large metadata. Now, how do you deal with that when you have a proxy, right? Particularly, you brought up per packet metadata, right? Do you preserve all that metadata as the packet traverses through the SF? Right, that's one comment. And the other one is there has to be, first of all, the metadata itself is use case specific, right? The use cases have to define how the metadata should be used. And now we also need to think about whether there should be provisions in the header itself to indicate if some metadata needs to be preserved through the SF or the proxy, or if the metadata itself has to encode this into the header.
Right. So a couple of good points there. First of all, I guess, is there a use case for per packet metadata that we wish to support? Or is all the metadata describing things like subscriber identifiers and things that can be cloned from packet to packet? And another point is, should the packet be self-describing? In other words, should the optional metadata have a flag in it to say what type it is, or should this be a configuration thing? I think that's something for the group to figure out.
Just hold off there a second, Joel. Has anybody not signed the blue sheets? Because I have a blue sheet here, so, okay, I'll throw it down there in a second. At the back, question, you've been waiting a while there.
Yes, Joseph Karagianis here. Regarding the question if this work is needed, I think if we think that migration is important, so and we would like to focus on type of scenarios where include a hybrid type of nodes, SVware and SV anywhere, I think such work is very important. Of course, the issue regarding the metadata is important, and I think in order to tackle that, we have to define and to work out what are the different types of metadata. And in order to do that, maybe we should work in examples first to identify and classify such metadata.
Sure, I'd really love to see a discussion about this on the mailing list. And also pointing out again that these metadata issues are not just for the legacy functions, but any function that needs to inject a packet needs to have some idea of what metadata to add to it.
Okay, thanks.
Mm-hmm.
I have to say, this is Joel Halpern with Ericsson. I think the notion of making a standard about how proxies work is exactly backwards. The reason for proxies being in the architecture is because we know there's legacy things which work in a myriad different ways. And we can't change all of them overnight. We can't teach all of them overnight to work with NSH. But the corollary is we also don't get to say, oh, change it so it works this way or that way. We can't pick the ways. The proxies are going to have to be built to work with the different ways that service functions work. Now, if we want an informational survey document on some of the ways of building proxies and what they can and can't do and which kinds of functions they can or cannot work with, as an informational document, I can't oppose such a thing. As a survey, not as a normative list, not as a definitive list, because standardizing a proxy is not actually possible. And getting into, oh, we are going to restrict the metadata because these proxies can't work with it. No, the service function chaining has to define what we need to do. There will be lots of service functions we can proxy in one of, I can think of 10 different ways at least, and that's unfortunate, but it's the reality that's out there. And there will be some that we cannot proxy. Okay, if we solve 90% of the case and the operators have to work with their vendors for the 10%, that's reality. saying, well, because of that, we must restrict service chaining from doing what it needs to do, is backwards. And just to get to your TCP thing, there's multiple ways to solve that in the architecture for things which are willing to be NSH sensitive, and they may or may not be able to use configuration of reverse pathing. There's lots of answers to that. And that's, but particularly for proxies, there's so many different ways that depend so heavily on exactly how the service function works, and whether it's a VM or a legacy device, whether it preserves VLAN tags or delivers MAC headers at all. Different ones function differently. I don't see any value in trying to standardize any such beast.
Okay, well, could we standardize the behavior of metadata for standard SF functions? So the injecting a packet with which metadata should be added. So for putting the the proxy aside, how does an SF attach? What metadata does it attach to a packet that it adds?
No,
Can we standardize that?
Yeah, just a comment on what Joel said. The way I'm looking at this is it is not just the proxy. I mean, some of these issues apply even to the SF itself, because you have to codify how the SF should be dealing with this metadata. I mean, if the SFF is expecting some metadata to be turned back, then that has to be codified as to say that this needs to be preserved. Either that needs to be done in the metadata itself or as a standard mechanism. But how the proxy should behave, or whether that should be standardized, that's up for general discussion.
Sorry, this is Joel Halpern, just clarifying. The way we've defined things, SFFs do not have expectation on metadata. SFs do, services do. And we may need to specify that when we define metadata, whether we define it or whether there's a registry or whether other people define it. Definitions of metadata have to define their expectations. But the SFFs, the service forwarding functions, don't have expectations on metadata. That's the way it's structured.
Mohammed?
Yeah, Mohammed Boukadia from Telecoms. I am in the opposite side of what has just been said by Joel. I think that's one of the reason of failure of various protocols here within IETF is that we always left the specification of the proxies out of the specifications, and this come up with fuzzy behaviors that we don't even expect. So I do see a real value to specify a minimal or a simple SFC proxy. So this is very valuable work. We have to agree on specificities because there are something that are out of scope. So I do really see a value in this work. As for the first comment that said that this will be complex, all what we are doing here is already complex. This may be more complex, less complex, I don't know in advance, but this is in the same level of complexity that we are already done. So thank you for working on this document.
Martin Horn. Back to the actual proxies, for the legacy service functions, how do you in the proxy expect to actually rendezvous with the same packet from the original flow and reconstitute this metadata that needs to continue on?
So, one example is to, for the 5-tuple approach, you can be stateful and remember the metadata that goes with that flow. Remember the path identifier, the path index, and other things. As described, you could do similarly for VLAN, right? You could say each VLAN, this VLAN represents this path ID and this index.
You have to keep state, and then you have to age it. You don't know what the service function will do. It may drop the packet. It may modify it. Who knows?
Yeah, I think it's quite likely that the proxy is keeping state, yes, on hopefully not per packet, but on some other basis. Remember the proxy is kind of tailored to work with the legacy device.
Yeah, it seems very clear that whoever wants to participate with a legacy device has to provide the proxy.
It's quite likely.
So Happy. Also, I agree with Joe that there are so many different kinds of legacy service functions in this world, but I think for this work, if we can investigate the existing like service functions and if this spec can solve the problems for most of the legacy functions, for example, if we think the majority of legacy functions are transparent, I think that's enough. That's the value of this document. Thank you.
Right, I think that a lot of them are transparent, and you may be able to come up with a way that works for all of those.
Hi, this is Paul Quinn. I'm a little concerned that we're maybe delving into over-specifying a proxy at this point. You know, stateful, not stateful, and so on. I'm a little concerned. I think, in my experience, you know, a relatively simple stateless proxy can solve many cases, not all. And you know, I kind of echo Joel's comments that if we delve too far down this path, we might not have an end in sense.
Mm-hmm. Yeah, it might be useful to just restrict the scope in which these can work. You know, for example, without metadata.
Yeah.
Thank you.
Okay, thanks. Thanks, Dave. Surrender, I think you're up next. If I can get this thing to work here. Let me just check if I can get this to work, because I think I might be able to do it through preview. Yeah. Let me just check and get this to work here, Surrender. There we go.
Okay. So this is Surendra from Cisco. Yes, this is a new draft with old content. I presented this at Honolulu, primarily to talk about the optimization of the service path. We have made some changes since then based on all the feedback and the questions that we received at Honolulu, and that's reflected in this quick update. Next slide. So to basically recap, we presented this offload mechanism or the optimization mechanism wherein you have these simple offload bits in the header, in some part of the header, you know, whether it's metadata or a header, base header itself, that is debatable. That will tell you whether to offload the flow to the SFFs, and further, as part of stage 2, you could extend this to propagate these offloads further upstream to different SFFs, and in that way you get an optimum service path. Next slide. And we also presented how this is beneficial in the sense that when you have different service function chains with different service functions shared across different service function chains, you can have the effect of distributed service delivery by doing these offloads across different SFFs. Next slide. So this is a summary of all the changes that we have done since. The one thing that we heard from a lot of people, both at the open mic as well as offline discussions, is that the second stage is a bit involved in terms of implementation, and we went ahead and separated that from the stage 1. Stage 1 is primarily the local offloads, where you indicate to the SFF that flows does not have to be steered, and that's simple enough, right? And that uses just 2 bits to achieve this. And we kept the old optimization as is in the original document. It is not updated yet, but I'll get to it soon. The other primary change is that the bits that were used for offload are now reflected in both the MD type 1 and MD type 2 header formats. Next slide. As next steps, if the working group thinks that this is ready for adoption, we would request a call for adoption. And the
original draft can remain as informational. That does not need to be adopted by the working group. Of course, we request additional review of the document and comments.
Mohammed.
Yeah, Mohammed Kader from Steercom. I think it's, yeah, the objective I think it's interesting to work on this topic, so thank you for doing this work.
Okay.
But I think that there are various ways to achieve the same objective, so that's why I think it is too early to discuss whether we have to force this in the header itself, because we can do it at the control plane itself, or we can just change the classification rules in the classifier itself, or to interact with the service functions themselves. So I do think this is something that is worth to be considered by the working group, but not right now. So it is too early to discuss these kind of topics. Thanks.
Thanks.
And this is Linda Dunbar. I like Mohammed's comment. I think his good work is a very simple optimization. And I do think that there should be delay considered together with the control plan, because as a SFF, you get requests from control plan to change the path, to change whether you need to offload a particular function or not. And here's another way to do it. Maybe it's better, maybe simpler, but there's also cost associated, because SFF has to consider two inputs. So I think it should be considered together. I think it would be more optimal for the working group.
This is specifically in the data plane. This is not a control plane protocol, but we did discuss extensively in the draft, if you read it, about the different mechanisms that are available for removing a service function or a set of service functions from a service function chain.
Yes, I read your draft, and I also sent your comments comparing with the control plane, and there's different ways to achieve same
Yes,
function.
we did contrast that.
Yeah.
We did contrast that, and there is also this bypass bit that is mentioned. We need to talk about that as well, which is same as offloads.
Right. So just my point is, there are two different ways to achieve the same purpose. So those two different ways should be...
No disagreement. There are more than two ways of achieving this.
Multiple ways to achieve
Yes.
it, right? So, but big scope is one data plane changing the path, one is control plane changing the path.
So this is not changing the path. I mean, that's a subtle point. We are not changing the service function path. This is still the same service function path.
I understand.
Yeah.
You don't change the ID. I understand that. But you're changing out of the path. You bypass a particular function, right? So that is the rendered path is different, right? So it's same as changing the path, but that's just one light point.
Well,
So
Go ahead.
So when you say changing the path, I mean, now we define path based on the path ID. The path ID always remains consistent and same, right?
Correct. So if you go to look at other working group, there are draft already indicating you have same path ID. However, the function, this particular flow visit can be different. You can change using control plan to change.
It can. I
each
mean,
function.
I'm not even disagreeing with that. There are multiple ways of doing that, and that is contrasted in the draft.
So I'm not debating with you.
Yeah.
I agree with you. I'm just saying it should be considered together with the control plan. That's all my point.
John Messenger from ADVA. The way I understood the stage one part of this is that some service functions simply couldn't keep up with the number of flows that needed to be going through them, and once they'd seen early parts of the flow, they were then satisfied that that flow did not need further examination. And so it was a way of managing load on some service functions. And that seems to make a great deal of sense to me. And from what I understood also, there are different ways of achieving that, but you need to achieve that in very quick real time.
Yes.
And I think that was the justification that I'd heard for the bypass or the stage one approach that you described.
Yes, that's
So
exactly right.
that much I fully understand, and I think that's going to be important. I think that should be
Yes.
part of the solution. In a way, it doesn't seem to me like changing the chain. That service function that said it's done examining that chain still kind of owns the right to that chain, to that conversation. It's just decided that now it doesn't need to actually interact with the detail anymore. So I don't see it as perverting the original function. But I do also agree with the idea of separating these two ideas that you've mentioned. From the slides that I've seen this morning, I can't understand what stage 2 is all about. So I think progressing with the stage 1 stuff separately is a great idea.
Okay, thanks for the comments. As you said, the SF still controls. It is first of all, it is a best effort mechanism, and it is a request by the SF, and that does not mean that the SF needs to honor. And the SFs are still operating under the control of a controller policy plane at the top.
Diego Lopez, just as a reflection in general to some of the comments that I've heard, probably it's a little bit premature to go through, let's call it, make an RFC of this, because there are other documents that are on the way. But anyway, I think it's a good idea. It's well expressed. So let's keep it. I mean, something that doesn't make any sense. Even if we delay a little bit the whole process, that maybe makes sense. But anyway, it's valuable and it's there. So
thanks. Yeah.
Andrew Dolgan, Alcata. As much as the idea looks okay, we should really ask ourselves, do we really need it? Because if we're moving to virtualized world, you have VMs, you have capacity, you can write if you know how to write software, you can bypass 90%, 95, 99% of what the processing for a flow requires once you don't need it. So putting stuff in a headers data path, it's back trying to get stuff from applications into a network, and that's fundamentally, I think, miss the point.
Actually, I don't understand what you mean by a virtual environment where you can do things, right? Well, if you can clarify that.
If you're doing service functions, and those service functions run on VMs with CPUs, this is not appliances. That's where we're going.
No, the issue is not...
If it's a software, it's very easy to implement a complex functions that require a lot of computation that locally can bypass majority of processing when the processing is no longer required. So you're not saving that much by adding complexity into a header. Okay, you're going to save link on the bandwidth towards that thing, and if you need more, then there is a control plane in a classifier that can change then the path. Like at the end, I think we're not, in the old world of appliances, okay, maybe we would be saving a little bit more. In where are we going? I think we over-specifying here.
I mean, this is not about virtual function or physical function. This is, the issues are the same, except that, there is a great deal of flexibility that you get with, virtual environments, right?
Seriously, the issues are not the same when you're running VMs and when you're running appliances. Like, it takes a little bit more effort to put an appliance than to spin a VM, yeah? If you need more capacity.
Now? Diego Lopez again. I really cannot believe I'm going to say this, but I had to disagree with that the things when you virtualize functions are so easy. Mm-hmm. I mean, I think there is a value here. And well, I'm afraid that in many cases, in real operations, boxes are going to stay for quite a while, and we have to deal with them. And if we don't deal with them in the right way, virtualization won't happen, simply.
Okay, thanks, Surendra. You're up again. I think I'm good here, actually. Yeah.
Yeah, that's better.
Mm-hmm.
So can you go back, please? So I'm presenting the draft HOMA SFC forwarding method analysis. And again, my name's Dave Dolson. Next slide, please. Okay, so the purpose of this draft is to investigate, different network design patterns and different methods of forwarding related to service chaining type problems. And our point here is really we want to enable conversation about deploying this, and there's seems to be quite a bit of interest in this question, especially from large service providers. So that's kind of the viewpoint we're taking here. Next slide, please. So in the draft, we break down, we look at different forwarding methods, right? So there's basically different ways of getting packets to follow a certain chain. Right? So the first case we look at is we call based on flow identifiable information, and you might think of this as the open flow approach. This is where each forwarding node needs a table entry for every 5 tuple, or more or less, to decide where it should go. I mean, you can also do this just based on IP address or something like this, but the main point is without modifying packets, you could get them to take certain paths through the network. So this is suitable for small or fairly static networks, but we have real concerns about the scalability of this approach. The second case is we call it stacked transport headers. So this is, for example, if you create a stack of MPLS tags along the spring lines. And this is really a source routing approach, where the classifier chooses explicitly each node that is to be visited and creates a stack of labels. Now this does use existing technology, but we have concerns here about increasing the packet size, and also in such a way that it's not really deterministic how big the packet might need to be. So it's hard to have a deterministic path NTU. And then when you get that, if you start fragmenting it, you have network efficiency problems and so on. And then the third method is the service chain ID, and this is the way the NSH works. This is where you have a fixed header with a forwarding tag. This does seem to have some good properties for large networks. You do have to upgrade equipment, but we do conclude that this is applicable to large-scale networks. And by large scale, by the way, we're talking about millions of customers and thousands of service functions. Next slide, please. We also talk about different path selection patterns that you can use. So what we call the static path is where at the point the packet enters the network, it's put on a path that will deliver it all the way to the end. So this is like one controller for the entire network, setting up all the forwarding tables. And there are a couple of variations in here. In one case, different SFs share a path, and there's also a case where you have a distinct service function for each path. But one of the drawbacks here is for a really large network, you can be controlling a large number of forwarders from a single controller. So the second pattern is we call the dynamic case, which is you can think of a packet traversing several domains on its way to exiting the network. So this would be, classify, send it through a few hops, reclassify, send it through a few hops. And what you get here is you can have different controllers for each of those segments. So you can, in some way, break the problem down so that you have controllers for smaller parts of the network. And this way you can avoid a super controller that understands the entire network. Next slide, please. So one of the patterns we investigated or discovered while looking at these different options is what we call the hierarchical service paths. And this is where we look at the high level of a network, you can create fairly simple path constructs. And a service function at the high level, if you look inside that service function, it can actually be a domain of its own, an SF domain. So what you end up with at the high level, you can have fairly simple classification rules. Basically, the idea, you can think of it as, let's get the packets to the correct data center or the correct rack, and then we'll deal with it controlled in its own way, its own domain. And then inside the low-level one, you can have highly stateful, rapidly changing, highly controlled, elastic approaches, without rerouting paths across your entire network. So next slide, please. We have some pictures. So on the left-hand side, I'm showing the top level of hierarchy. Now I'm showing two paths here. It's a bidirectional path. Incoming and outgoing packets. In this domain here, there are just two service functions shown. Inside each service function, shown on the right-hand side, is what we call a subdomain, where we've called the SF domain proxy is, I think we're going to change that name to gateway, but that's on its left and right interfaces. It's pretending to be an SF, and internally it's sending packets through a variety of service functions. We've shown this as a stateful classifier, so the same device is classifying packets coming from the left and the right. So because the state is localized, you can think of that being rapidly changing, flow-based, possibly based on DPI, rapidly updating. Whereas in the high-level domain, again, that's the point of, let's write some classifiers that just get the traffic to the correct subdomain. So you might think of, as an example, I have different classes of consumers. Let's get the residential subscribers up to the top one. Let's get the business customers to a different one. And what you get there is, the top level is a domain of administration that's, fairly simple to think about. Then inside each subdomain, they can be independent of the high-level domain and only deal with the specific problems of that domain. You can even have, the responsibility of administration by independent groups in your organization. So next slide, please. So unfortunately, this introduces a new type of component. In the draft, we called it the SF domain proxy, but in the next revision, we think we'll rename it to SF domain gateway. So this is, the gateway or the bridge between different domains. As I said, it looks like a service function at the top level, but inside it looks like a classifier. And I've already, mentioned some of these, but we think that using this, really helps you think about deploying at the largest scale networks. So we'd like to think about, the working group actually, discussing this, and I don't know if it belongs in the architecture explicitly or not. It does cross, we recognize that it crosses multiple domains, which is in some sense said not to be in scope. But we also think that we've seen so much interest in this that we think it's worth continuing to discuss it. So next slide, please. So we think this draft itself should progress this analysis of different forwarding methods to provide, a terminology for different service providers and vendors to talk about the kind of solutions they're offering, what the drawbacks are and what the favorable features are. And we, and we're also, if there's some interest, we're interested in creating a separate draft that just discusses the way this hierarchical approach works and describes the behaviors of this SF domain gateway. And we're also, of course, we're asking the question of should this be explicitly mentioned in the architecture as a feature. I should also say there was there's a similar concept was mentioned in another draft by Dapeng Yu, the draft Liu SF nesting. So it's kind of an independent idea. So any questions or comments?
I'm Shinsuke, and I am an author of this draft. I believe that this draft will be helpful for clarifying the advantages of service function chaining compared with other methods. As you know, there are many methods to achieve such chaining, and many service providers are wondering which method is better. So this work is important. So if you have any opinions for our analysis, please let us know. Thanks.
Yeah, to reiterate that, we really would like you to read this and give opinions and further cases in this discussion.
This is Dr. Liu. My affiliation is Alibaba Group. As David mentioned, I'm the author of the SSV nesting draft. We think that in a large-scale data center, this architecture structure, or we call it architecture or nesting, is very important. And it was an independent document to describe the use case, the potential impact to the architecture, and maybe extensions to the NSH header. So we think the working group should consider that.
John Messenger from ADVA. I have a question about the meeting materials for this session. I found that presentation very interesting, but I can't find it on the meeting materials page. Are your meeting materials anywhere near up to date, or there seems to be a disconnection?
No, it is on the it is on there. I'll help you afterwards.
Thank
but
you.
I'll double check, but I'm pretty sure that all of the presentations are up there.
Okay. And oh, it's the order that's the problem, is it? Okay. So, but just in general, in support of the analysis, I found it very useful. Thank you.
Hi, I'm Dirk Kutscher with NEC. So I think that's a useful document. I had two questions regarding your analysis of the forwarding methods. So when you talked about scalability, is that like more a theoretical concern that you expressed, like for OpenFlow, or is that based on any, say, numbers or like deeper analysis? So can you quantify this, or is there a plan to do this?
So I think the concern with OpenFlow is for the number of table entries you may need to put in every single node across your entire network, and if you could take an approach where you can any given forwarding table, because if you break down the problem in stages, the top level forwarding tables only need a few entries, and then you send that to a cluster where they can have a fewer number of entries. So the idea was, and I think this similar applies to not just the OpenFlow approach, but also the NSH approach, where you need to have a certain number of forwarding entries for a number of chains. So if you can keep your number of paths small at different levels, I think you can scale better.
This is Joel Halpern. I have a terminology concern. I have no problem with drawing a distinction between 5-tuple-based forwarding, NSH-based forwarding, transport stack-based forwarding. That's fine. Has nothing to do with what control protocol you use. I can use OpenFlow to set up MPLS segment routes. I can use PCE to set up per flow classifier state. Your scaling point is about what kind of state you need, not what control protocol you use. So please, and when you revise the document, be careful not to mix control protocol mechanisms with the actual forwarding plane analysis. They're two separate dimensions.
I would agree with that. Yeah, thanks for that feedback.
Any further questions?
Can I just ask how many people managed to read this? Okay. Good to see that. Okay, thank you.
Great. Yep.
I have another question coming.
Yep.
Ramki Krishnan, Dell. So one aspect which is not very clear from the presentation is, what is a new problem you're trying to solve? Is it about, multiple administrative domains within the same operator, or across operators? What is the intention here?
Our intention so far has been within a single operator, but breaking down the problem into different domains of manageability so that we can think about having multiple controllers, each dealing with a subset of the problem, possibly under different groups within an organization, or even just breaking it down for, just so each controller can be simpler and more easily reasoned about as well.
Okay, thanks.
Thanks, Dave. Samantha? Yeah.
Good morning. Good morning. So my name is Nandra. I work for a company called F5 Networks. So although it's a topic is L7 optimization, so I was taking notes while lots of people are asking questions. So I took some of the notes which probably would help this topic that I'm going to talk about. So there was a question about does offload matter? So that's really a good question. And I'll try to put a perspective when and why the offload matters to the operators in terms of actual cost per bits. There was one more question about can control plane solve all the problems? Do we need in-band signaling? So that's the other question, so I'll try to answer. And the third question, I think, pretty much came out all the time was that given a flow, let me define a TCP flow for this purpose. Or if it is 5 tuple or 6 tuple, can the metadata change when a particular flow is going through a service functions? So I think that's what will help. This is not related to draft, so you can't question me anything about whether it's going to be drafted, so I'm free from those questions. So let's move on to the next page. So what's the typical attributes of L7 devices? It typically manages the life of a flow. And I bring it up because oftentimes a flow is defined by 5 tuple or 6 tuple. Correct, but not fully correct. So for example, if I have a SYN which creates a flow manager actually manages the flow until the flow is dead, which is in TCP terms, I have to get a FIN-FINAC or I have to get a reset. It is utmost important for the security devices to actually track a flow. So 6 tuple doesn't cut it if I'm actually looking at a flow from security perspective, because an intelligent hacker could actually figure out what's the source port and actually bypass all your security mechanism if you offload. So it's important considerations to make. Cost per bits is really much higher compared to switches and routers. And in one calculations we did, it was about 10x probably. So in real terms of operational cost, offload would matter to you. There was one question from far back is that everything can be solved by software. Yes and no. If you have too many softwares running with bunch of controllers, trust me, it doesn't work well. So you probably need some big honcho box still doing some of the heavy lifting, which is a branded stupid thing, but it's fast. And that's where we're trying to go. And what makes it difficult is this L7 devices are typically very, very stateful. Other than your 5 or 6 tuple flow information, you typically have many informations about the application itself. So I work for a ADC company. We track the application state, what the application is doing, what's the HTTP header, what state of HTTP processing I'm in, a whole bunch of state. So failover is very difficult to do for us because it actually has a lot of states. And The devices themselves also handle streams in many different ways. It could be a full proxy, meaning like 2 sites of TCP is broken down, means like I break down a TCP stream in 2 circuits. I can break down the TCP stream 2 circuits in the beginning of the flow and then can splice them back. And I could basically just work like a router. Next slide, please. So this is where, this blue line is what, when I first get a packet, press the next button, please. So what happens is that if I am in actually a splice state, which means that a typical load balancer would get your SYN, it will actually send a SYNAC, and then we'll figure out who I am going to talk to. It's like an add device. So if you look at the state, and then it's basically splices back. So if I want to offload at that point, there is no other way I can actually tell this SFF entity, this is the time for you to offload. So that's where comes the first answer to the questions, do I need the in-band signaling? If we propose a offload mechanism, then I do need a signal to tell the SFF, now you go ahead and this is the state, which is a checksum deltas and some of the NAT states, and you can go ahead and offload it. Does it need to be NSH error or not? Depends on the design. It's not really required. So all I'm actually sending, the offload mechanism also have to have some states also to be considered. Next one, please. And look at the green line. So as I said, most of the time, the service function, in this case ADC and all, or the firewalls, want to be in the control of the flow all the time. It's, I think somebody, John, had asked that question, is that, yes, I do offload for fast packet processing, but I'm still in control. So when I need the control back, I want to instruct the forwarding agent, give me the packets back. And typically that can happen at any kind of, most likely it will happen at the end of the flow, because I want to know the flow table has to be parsed. So not only I need an offload, I need a sort of an on-offload, means like, now give it back to me, onload, I don't know what the term to use. So when you are talking about offload, don't think about just offloading all the time. You want the control back too. So that's the second point. And when you offload and onload both of the times, we have to be worried about the packet ordering also. We can ignore that, or we can also do a solution. I'm not proposing that solution should increase any kind of another bits in the packets or not, but that's a concern to be had.
Can I interrupt you for a second? It's about how could the function decide that it wants the control back when it's not seeing anything about the packets? If it has been offloaded, just...
No, I can tell you why. It's basically the function, it depends on how the SFF is designed, but typically I want control back at the fin.
Okay, so that would be something like requiring some kind of callback or something like that.
Correct.
More than...
Yeah.
Okay.
Yeah, it's like this is the uploading the
yes.
the bypass facility, right?
Right. So
effectively asking for a method to... Sorry, John Messenger from Adva. So this is where you would like to be able to instruct the SF effectively which parts of a flow you want to look at. So that it's quite complicated, you know, and again, it makes me think you need to design your function so that it plays in the SFC environment, because otherwise it's effectively, again, back to the point Joel made about the proxy. It's really becoming a proxy to offload effort, whereas it might be better if the device itself segmented the flow that way itself.
Let me think about the question. I probably didn't get it completely. So
can we hold? Let's
just finish it.
Here before we take any more questions.
Next slide, please. Okay, so this really answers what I'm trying to answer is that why offload does matter and what point of offload it actually. So in a ADC or any kind of a security device which actually is really looking at the lot of the packets, there is a flow setup and there's a whole bunch of transactions. So I'm just taking it typical transactions of HTTP. So think this way, a typical HTTP response is about 16K. So we are looking at a heavy lifting of processing about every 16 packets. Take full 1500 bytes, and you're looking at a 15 to 20 packets gap before you actually do a lot of processing, right? The part that the 90% of the bandwidth is used on the response side, right? So it's great to be in the business of in the bidirectional flow, and most of these devices are bidirectional. But it sometimes makes sense to offload when we know that this flow, we really don't have to do much. So what we are leading to is that we want to offload, but still again, we want to be in the control of the flow, but we want to offload one directions. Meaning like that particular device needs to be engaged on the forwarding side because he can see what's going to happen from the client, when it's going to send a fin or when it needs to actually finish the flow, so they can instruct back to the offload device. But it wants to cut it off from the costly part of the bits that is actually touching the CPU all the time. Next one, please. So this is what the one-way offload really means, is that it's still engaging the forwarding side, and it remains to be, it needs to be engaged, but the reverse direction actually can bypass lots of the functions, or it can change the path. So it goes and says this offload box or function, whatever you call it, and I kind of don't want to use the term protocol, but we probably need some helper bits in the NSH if we want to go down the path of saying that, okay, this is the time at this point of the context in the data stream, go ahead and switch off. Switch on the offload, and there'll be kind of offload back or unload back. I don't know how to say it. And so it's a sort of a start of offload, end of offload, and it gets back the flow control. Next slide, please. So this is the key point that what we're trying to say. So, I mean, don't look at it as any kind of a design. This is a PowerPoint picture. Most of the flow processing device works based on some kind of events. And as I said, why events is basically if the flow devices has to look at every packet all the time, the cost is too high and will be really slow. So one of the issues with the NSH is it's a packet-based encapsulation. That screws up the flow hour devices really badly. So there are two choices, design choices. We have to look at every packet to figure out if there is a metadata, and I have to figure out whether NSH actually provides enough entropy. There is no discussion about that yet. Or we ask in the NSH itself, give us some help and actually classify, or somebody is responsible for putting some kind of indication that when the metadata is changed, these kinds of devices can quickly look it up and say, oh, I need to be in the processing path because there is some metadata available that I need to do it. So what we are basically asking for is that there is some kind of event helping functions that better be there on the NSH protocol itself. Again, not a protocol, sorry, encapsulation. Next one, please. Oh, I already said that. Okay, so at the end of the day, it may be premature, but the bits are always costly, given so many people asking for so many things. So I also want to get in line. So it basically boils down to, I think, in the NSH encapsulation, we probably have to think about, we need a offload start-stop kind of thing if we want to go down that path. And I would really like to see some kind of a transaction ID version bits for efficient detection of the change in metadata. There is a company and draft that Paul was mentioning. There is something called, I forgot, service level tag, which can be used for that. The question would be, do you make it a part of the general encapsulation or certain MD type and things like that? Or we don't do it. That's all.
Okay, you got some questions coming up. Quite a few.
This is Linda Dabra. I really like your presentation. It's very clear, shows why we need to offload. That's great. My question is, when the service function decide to offload, right? As you mentioned, there are two ways. You can send a message to the switching, hey, please offload this kind of traffic with this policy, right? That's one way of doing it. Another way is encapsulate a bit in the packet, attach the packet to the SF, back to the SF. Which way do you prefer, and pros and cons?
So let me answer. The first method you were mentioning was?
You can send an independent message, not necessarily attached to another data packet. Just say, hey,
Gotcha.
please offload.
Gotcha.
And then when you need to say, please backload.
Gotcha.
Actually, two separate messages.
Gotcha. It's a difficult question to answer, but I would say if I have to synchronize between the data stream bits and offload, there's almost no choice but to put it in there, because independent message, you can never really guarantee a synchronized delivery of the message with the data stream. How do I synchronize that I want to offload right after my HTTP header ends, let's say? How do I synchronize that message? There are multiple ways to do it, but that will be engineering-wise, that will be very challenging. So that's the point for putting it inside the data stream. So the event and where it's supposed to happen are synchronized by very definition of carrying it along with the data.
Well, thank you so much. Then the next question is, once the traffic offload, the traffic doesn't come back to me anymore. I think John Messenger mentioned that. How do you tell the switch, hey, send the packet back to me?
Multiple ways. I mean, there could be, I'm giving you the examples of how today's modern load balancers are designed, right? Most of these load balancers as well as firewalls, and everybody does offload inside their own data path. And typically they are looking at the fin bit. That's one example. I could be looking at the length of data path, so I would be looking at the sequence number to figure out where to actually again get, get my interest. There are many ways people have already solved this problem. So now, does it mean that we need to standardize it? Nah, that's just too much engineering to do. You don't need to. So what we do need is that this is the point you give me the control of the flow, and this is the point where I give you back the flow again. What exactly is the logic for that? I think we don't want to standardize this at all. That's my personal opinion.
Eric? Over here to Intel. I want to start from Diego's question, because I actually had exactly the same issue. If just to draw kind of two extremes, you could say, as long as you say bypass, I think I'm on board. An SF has done some work, determined that it is off the hook. You want to set it loose, that's fine. But the problem is with getting it back. The minute we want to have some specific logic, and just your last comment was, maybe I don't want to even specify that logic. It sounds to me like one way to model that would be to have a more feature-rich SF and a little bit, feature-poor type of an SF, and then it becomes a game that you really play with the existing semantics of service chaining, rather than overburden the basic protocol with, oh, here's a signal when you go on, where you go off. So if this was just a bit to say, oh, I'm done, cut me off, that's fine. The minute we want to start adding all sorts of logic, and there are many cases, then why not play it with with the already existing mechanisms of different SFs and how they communicate?
You're right. I'm not saying that, I'm not trying to overburden the protocol. In fact, I was very against calling MSH a protocol, but I think we almost have no choice to make it a light protocol. So let's pretend it's not a protocol. So that's why I said let's bit or begin. So what I'm really looking is to have some bits which says, take the flow from me, and I almost probably don't need a bit when it gives it back to me, because the SF, by very definition, who handed the flow to some lower entity would know when it's probably getting back. So I'm really looking for a place where it says, here's a bit or something which says, okay, on and off kind of thing.
Yeah. Said differently, I mean, I don't think we want to kick the can down the road. So if somebody needs to do some basic processing still, you could say, I could have two threads inside my SF, and you lower the load on that SF. or there's no need to create a protocol where we need processing and we say, okay, somebody else is going to do that processing as long as that processing is needed. So the three options are have two modes inside one SF, has two SF in that case, feature rich, feature poor, or you push it to the SFF. If you push it to the SFF, we complicated that concept and we still need that processing. So.
Hey, I had a couple of comments. Firstly, in fact, I came to respond to Diego, but then after listening to Linda, I just wanted to respond to the control plane versus data plane signaling of offloads. I mean, it is all about the reaction time, how quickly you want to react to this, because you have flows that are moving at very high rates. If you try to use the control plane to do this, you probably miss the opportunity. By the time you get to that, you may not be even having that flow. That's the first point. And the second point about how we implement it and how we encode these offloads. I mean, there are various ways of doing it. I mean, you could have a simple or implicit definition of this wherein, just the way you were saying, based on the fin or a certain amount of data, the control plane or the entire solution can define that offload will be done at this point. And if you read the draft, we specifically used a TLV in MD type 2 with certain bits, and this is mainly for extensibility. You could potentially have additional bits dictating how this offload stops. You could set another bit saying that, I mean, this is all just making this up as we speak, as to say that when you see fin, I want this unoffloaded, right? I mean, this is just an example, right? And to Uri's point, there are different levels at which you can implement offload. Can all hardware implement it? Maybe not. I mean, you can implement at different levels. You can implement the simplest offload in hardware. Maybe if you need to maintain flow state that requires large number of flows to be maintained, maybe it's not feasible in the hardware.
So thanks for bringing some at least of complications that the previous presentations were maybe short on. It very well shows the complication of the whole offloading problem. You're not going to be offloading short-lived flows. That's just too many too quickly. So we really would be looking at long term. And now we went from one bit to multiple bits to protocol. This is not easy thing to do. So I just wanted to ask you, how do you think, does it make sense to move functions and make the forwarding devices in the network more complicated to the versus implementing what you're saying can be very well implemented in a function itself, limiting the bandwidth and limiting the load on the function itself. It's been done. Any level 7 device that I know was implemented does that.
So let me respond to a little bit to your question. Is that first a clarification? So at the end of all this presentation, what I've been probably asking or requesting this WG to consider is, can I have a bit, please? Right. So let's not call it a protocol. Okay. And then, do I want to clarify that bit further with when to offload or unload? That's a separate question. That's when I get into the conversation of, do I need a protocol or not? That's probably a little farther out, and most often, the way I probably see it, the SFF and SF in many of these cases where they're offloading, I could almost say it's not going to interoperate in the first day. It'll be coming from the same big company, starts with C or something, that'll say, here's the device, here's the other device, and we play nicely and we offload to each other. Because it really requires that kind of engineering integration. Or any other thing.
Yeah, but you didn't answer the question. Why would
I'm sorry, I'm going to have to cut this short because we're going to run out of time. So can you please take this? Let's take this offline because we spent a lot of time on this particular subject. And to be fair to the other presenters, we've got 30 minutes left and we really need to switch gears. So I apologize, folks. So Ronaldo, you're next.
Hello. I'm going to give a quick update on what we have been doing on Open the Light on the service function chaining front. Before I start, I have not developed all these features. Of course, hopefully that's clear. This was kind of a team effort. I was involved in these features, but many people contributed to them. All right, let's start. Okay, so the first one is that we did recently was service function chaining trace route. This is something that we developed because I have a few months back because I had no way of actually troubleshoot service function paths and was sick of trying to figure out if something was wrong and what was wrong with it. So I developed this. We developed this trace route that follows a service path and reports, every single service hop as opposed to IP hop, right? Okay, next slide. During the hackathon, we integrated service function chaining with netconf, which allows, say, a netconf device to provisions itself to the controller, and then the controller can use this netconf device as a service function forwarder. So basically we map the device constructs into service function chaining constructs. So there's a video there if you want to take a look. We are working on the integration of service function chaining open vSwitch. We have done a lot in there. There's another presentation about it, so I'm not going to go into a lot of details, but there is a video there showing the attachment of Open vSwitch and setting the manager to Open Daylight and Open vSwitch being used as a service function forwarder. Next slide. Some other things that we did. We implemented several service function load balancing schemes. So basically when you're constructing a path and you want to pick a specific service function to be part of this path, there are several algorithms that we have implemented. Of course, there's first come, first serve. There's round robin, so if you have 100 firewalls, we'll pick one in a round robin fashion. And we have load balancing based on CPU consumption, and there is random. And there are some others that we're working on, such as shortest path and things like that. We also worked on something called service function groups. So when you are constructing a path, instead of, say, choosing one service function, say, net, Dallas net, right? You can pick a service function group, and the service function group represents a collection of service function types, right? So instead of having just one service function, you have, say, 10 or 20. And from a service function chaining standpoint, they act as one, right? Let's see, next slide. Okay, so if you want more information, you can look at the wiki. Open Daylight has this control plane, and we also have a data plane implementation available, a reference data plane implementation available. Yep, I think this is it from my side. Anybody has any questions? All good, right? All right.
This question's coming.
Okay.
Daniel Miguel. I just have one question. Is that the group the same thing as a domain, or?
Domain?
I was thinking the same thing you've mentioned, Dave, about this concept of a service function domain in one of your presentations. So I think that's what you're referring to?
Yeah, exactly.
I don't know what a domain is. So service function group, as I said, when you are creating When you create a service function chain, and a service function chain is ordered list of service function types, right? You can see type, file, and then group. And this group name represents many different service functions of that type, right? So when you're actually forwarding the packets, the idea is that any one of those service functions is equally good in that group.
Okay.
Right?
Sounds to me that's like domain then.
I don't want to talk on behalf of Dave. I see some differences, to be honest, but I mean, conceptually, I can see where you're getting that from, but I don't think it's the same thing. Right?
So if you want more information on the service function group, actually there is a document written you can access on the wiki, right? Because we are limited on time here.
Ramki Krishnan, Dell. So when you talk about load balancing, is it dynamic in the sense, are you measuring some kind of utilization in load balancing, or what are you doing right now?
Well, there is one that is really dynamic, is the CPU, right? The other ones are random, first come, first serve. Those are we don't need to measure anything on the device itself, right? The one that's load balance, yeah, we measure the CPU on the device.
Only CPU right now, not other metrics?
Yes, only.
Okay, thanks.
All right.
Any other questions?
I can fit this here.
Thanks. Okay, let me find your presentation again.
Good morning, everybody. I am Shunsuke Homa from NTT. Today, I will report the feedbacks from interconnectivity testing of service function chaining by 6 companies. Their names are listed here. Next, please. Here is the agenda of my presentation. My presentation is separated into 4 sections. Next, please. First of all, I will talk about the purpose of this testing. As you know, service function chaining is a new framework, and the purpose of this testing is confirming the feasibility of service function chaining in real networks. For this testing, we mainly focused on 2 points. First point is connectivity in forwarding plane. Service function chaining provides forwarding based on a new header format, and we confirmed the connectivity with actual devices, including actual service functions. Second point is confirming multi-vendor support by using multi-vendor devices. A network composed of single vendor devices has a risk of service disruption. So this factor is very important for service providers. In this testing, we confirmed these 2 points. Next, please. I will introduce an overview of the demo. In this demo, we showed 2 advantages of service function chaining. The first advantage is easiness of switching service. In existing SDN technologies such as OpenFlow, configuration of each forwarding function, changing configuration of each forwarding function will be required for changing service paths. On the other hand, in service function chaining, we can change the service path by changing only configuration of classifier. It's a huge benefit of using SFC. Second point is optimizing service chain. It's called path branching or reclassification. Path routing enables us to use service function more efficiently. And we provided 3 scenarios which emphasize these advantages. Next, please. Before explaining the scenarios, I will explain the demo structure. We established a large network, including multiple data centers. Service functions are distributed at each data center based on own features, and subchains connect the service functions across multiple data centers. This enables us to deploy service functions more flexibly. This concept is described in data center use cases draft. Next, please. And we use NSH version 3 and VXLAN GPE as SFC and transport headers. And in this testing, we didn't use metadata. Next, please. In the following slides, I will introduce the scenarios briefly. First scenario is security service. In this scenario, we showed a case that an operator defends a user from attackers by using appropriate combination of sub-functions, for example, traffic monitor, traffic analyzer, and firewall. Traffic monitors are distributed widely, and traffic analyzer and firewalls are located centrally. In this scenario, by using sub-function chaining, operator can steer abnormal traffic to traffic analyzer and firewall when operator detects abnormal traffic. Next slide, please. The second scenario is optimal communication service. In this scenario, we showed a use case of path routing with DPI. A classification based on application such as DPI is very expensive, so we would like to limit traffic going to DPI. Classifier at edge node identify data packets based on IP, and DPI changes the following path based on the application by changing NSH. Next, please. The third scenario is redundant chain. In the network with virtualized service functions, many service functions will be located at data center, and redundant chain will be required for a case that the entire data center fails. In this scenario, we showed a situation there where redundant chain is used. When a data center fails by huge disaster such as hurricane or earthquake, the SFF at the following previous data center changes the path to a redundant one by changing NSH. Next slide, please. Now, I will talk about issues in implementation of this testing. This section is separated into SFC service functions and management aspects. In SFC aspects, we could establish the demo without major issues in forwarding plane with multi-vendor devices. So we could confirm the feasibility of SFC. In addition, we found that centralized control may be feasible for SFC because SPI needs to be uniquely assigned in the entire network. However, centralized control will not scale well in large-scale network, so hierarchical approach will be required for using SFC in large-scale networks, such as carrier-grade networks. This concept is described in our draft. In service function aspect, we found that SFC proxy will be required to SFC proxy will be very important and need to be flexible because most of the existing service functions are SFC unaware, and there are various types of service functions and their connection methods are different. For example, some service functions, such as one accelerator, use VLAN for detecting session. So, in the same session, both incoming and outgoing packets must be attached to the same VLAN. When we use such service functions, we can't use VLAN tagging method as a proxy mechanism. From this, a document describing guidelines for SFC proxy may be required. In management aspect, we found that some OAM functions for confirming connection will be required. Because, as you know, data packet traverse various places in SFC, so it was hard to detect failure points. And I will now mention future work. In this testing, we could confirm the feasibility of SFC in terms of forwarding plane with multi-vendor devices. But it is specific to the demo. So for the next step, we should consider flexibility as important factor. For example, cooperating with control planes such as OpenDaylight, OpenFlow, or PCRF. In addition, we should consider redundancy mechanisms for edge cases such as error handling. Next, throughput examination of SFF and SFC proxy as software appliance should be done. SFC will be mainly used for connecting virtualized appliances. So SFF and SFC proxy should be implemented as software appliance. And finally, generalizing SFC need to be accelerated. It is necessary to migrate or create a service function to support NSH in order to be compatible for SFC. And we had submitted this demo to ETSI NFV as a proof of concept. That's all for my presentation. Thank you for your attention. And if you are interested in our demo, please contact me. I have them video and I can show them individually. Thanks.
Aaliyah Atlas, thank you very much for this presentation. It's really, really useful to see how operations, how actually proof of concepts, and how they're interoperating. That's very helpful.
Thank you.
Any further questions?
Nice presentation. Yeah. I'm Liang O. My question is just...
Could you lift the mic a little bit? I can't hear you,
sorry. I found you mentioned that there is no serious issues in forwarding plane in SFC aspect.
Yeah.
And that you also, in the last page, yeah, some SFC component work implements software, so throughput can be examined. So I want to know what's the performance of the forwarding plan you are achieving now. For example, 10 gigabits per second at a line rate or less. Yeah.
Throughput performance.
Yes.
Right? SFF and SFC proxy will be implemented as software appliance, so throughput issue will be very important, I think. Okay.
Hi, this is Paul Quinn. Again, I would also like to say thank you. It's a very interesting and very good proof point for the working group.
Yeah.
I have a question if you have any thoughts about future work involving metadata.
Metadata. In this demo, we didn't use metadata. So, but we also we also think metadata is very important. So in the next step, we would like to consider metadata use case. Yeah, thank you.
Yuri, thanks for the presentation. It's a very good work. Congratulate to you guys. I have two questions. When you do the service function training, you did mention that the packet you're using is V4, V6, or you test both?
Test both.
Did you test V4 only or V4 and V6?
V4 IPv4 we use.
V4 only, right? And then in that testing, do you actually have the net function running, or actually all the packet coming in is before net or after net, or you don't actually have testing any net function in the service function?
Did you have any net address translation?
Address, network address, we set statically. So
also, there's no net.
There's
no net. Yeah. The last question I have is, the VNI you use here, is it the VNI actually you use as the client, or you're using something else for the classifier?
Sorry.
So the VNI and the VXLAN header, were you using that for any purpose?
So the classifier you use in the, like you actually for the packet coming in, you mentioned that you have classifier in the edge router.
So configuration of classifier is also static.
And what do you use for the classifier? You use the VLAN tag, you use the VNI, or I mean, I'm just curious, like what you use for the classifier.
Classifier. Sorry.
So did you in the classification? How did you classify the packets? Were you using
classifier identify packet based on IP?
Or just based on the IP, the full IP address?
User equipment IP.
Okay. Okay. Thanks. Yep.
Suzuki-san, thank you for your presentation. Can you maybe shed some light? Where do you think the next things for NTT will be in this area to progress?
Next progress.
So the question is, where do you see the next steps that you would want to follow on from this part?
So we will submit this demo to SNFV as a report. And following plan is not decided yet.
Thank you.
You're welcome.
Many thanks. Again,
thank you very much.
Ronaldo, I think last presentation.
Okay, so last presentation before lunch. I'm going to talk about service function chaining and OVS, Open vSwitch functionality and status. This was a true team effort. Everybody here and others really pitched in. Nobody was, backpacked in this effort. So next status, please. Next slide. So in terms of SFC, NSH specifically, functionality for Open vSwitch, we have a data plane patch that brings NSH functionality into Open vSwitch. You can see the patch there, GitHub. There is an installer that takes care of most tasks for you. If you want to test dispatch with Open vSwitch, it brings NSH functionality. And we are working as we speak to upstream this patch into OVS. We have below here, I talk about what is the format of the NSH and CAP we use in OVS. It's a VXLAN and NSH, and the actual packet is VXLAN, NSH type 1, then it's Ethernet, then IP, then the rest of the packet. Next slide. So in terms of OpenFlow, we use OpenFlow to install matching rules for NSH. We tested this with OpenDaylight. OpenDaylight installing the OpenFlow matching rules. And as I said in the previous presentation, we also have integrated the OVS control plane, OVS DB, into service function chaining. There's a video demo there. Next slide. For those that like a little bit more concrete things, there is a dump of the OpenFlow flows from OVS that we were testing yesterday, and you can see the set actions, set service index 255, and service path 1. And anyway, if you want to talk and get involved, let me know with this effort or know more about it. I think that's it.
Sumandra, so the port 663 that you mentioned, it's a allocated port for this purpose, correct?
Yeah, it's a port that we are using for this specific purpose to the mux against the regular VXLAN.
Right, so in theory, I don't have to have VXLAN. I could send the UDP encapsulated packet, so I was just wondering if there's a possibility to answer without VXLAN or any other tunneling protocol.
Go ahead.
So I'll give a quick note about the OVS implementation to Samandra's question. This is Paul Quinn again. So the current OVS implementation expects to see that format when it sees the port 6633. 6633 is a reserved port. It was reserved for a Cisco protocol. We're happy to use it for NSH. However, the long-term plan, and not plan, but the long-term process for OVS is to move this to VXLAN GPE to support multi-protocol and use the IANA reserve port for VXLAN GPE plus NSH.
I wanted to ask exactly that question about 4789 versus 4790,
Yeah.
because so this is right now kind of
a demux
spliced together because actually you don't have the next protocol there.
Rather, I want to make sure we don't get into a little conversation here, but the OVS implementation does not ever send an NSH packet on 4789. It is just VXLAN on 4789.
Oh, okay.
This is just for illustration purposes.
There's no confusion on a parser. A parser will never see a 4789 with NSH.
Okay.
That should help answer your question.
Okay.
Okay, any further questions?
All right, thanks.
Thanks, Fernando. Okay, that's the end of the presentations. Thank you, everybody. I just want to check, has anybody not signed the blue sheet? Okay, if you could do so, if you could come up to the front and sign that on your way out, I'd very much appreciate that. That's it. Many thanks. Thank you, everyone, for attending.
Hello, it's Georgios Karagiannis here. I have a question.
Yes.
Regarding next steps and work on control plane. When do you think that we could start with that and have presentations on that?
Yeah, we had an initial discussion about how the working group would deal with control plane, actually earlier this week. We'll send out some notes on that. We have some ideas of how we're going to approach that, but certainly we're going to be looking more at control plane in the Prague meeting. And on the alias, moving up to Prague.
Okay, thanks.
Yep. You're welcome. Thank you. That'd be great, thanks.